Hi all, let's go ahead and get started with 6.2, solving some compound inequalities. There's 4 examples that I'm going to be working on here, so let's go ahead and jump in with number 1. Now on number 1, this one here, notice that it does not say or, so we already know that this one is an and inequality. Now they do not separate this into 2 inequalities to begin with, but we did practice that in class. So I'm going to go ahead and separate this to show 2 different inequalities so I know what my 2 values are on the number line. Of course, there's another way to do this without separating them, but the method that we practiced in class was separating them. So my first inequality is going to be negative 41 all the way up to minus 5. Okay? So I have negative 41 is less than or equal to 9x minus 5. So that's my first inequality. Now my second inequality as well includes the 9x minus 5, but it is going to be this information here. So then I have 9x minus 5 is less than 4. Now, please remember this is an and situation, which means the number needs to be between whatever these 2 values of x are. So let's go ahead now that we've got this split up, and let's go ahead and work on solving these for the variable x. Okay. Now, if it helps you, you are welcome to draw that line here that says whatever I do to one side, I do to the other. All that we talked about in class, that choice is yours, whether you want to write that. Now, I'm going to go ahead and add 5 to this side, which makes it go away, and also add 5 to this side. Okay. So over here, just so you see what I'm talking about, if I have negative 5 minus 5, or negative 5 plus 5, sorry, negative 5 plus 5, that's going to make this 0, right? So then we have negative 36 is less than or equal to 9x. Now I'm going to go ahead and divide by 9, divide by 9. 9 divided by 9 makes 1, so we know that part. So then I have negative 36 divided by 9 gives me negative 4. Let's pick up that red again. Negative 4 is less than or equal to x. So there is my first inequality. Now we talked about, for some of us, you guys said you like to write it in the reverse order, where you like the x value or the variable value on the left side and the constant value on the right side. Just remember that if you do that, you need to flip your inequality as well. Okay. All right. Now the other equation in this inequality, this compound inequality, is we are going to take this negative 5, move it to the other side where it becomes a positive 5. So then we have 9x is less than 4 plus 5 is 9. Then we're going to divide by 9. So then we have x is less than 1. All right, so there are my 2 inequalities. So now if I want to go ahead and place them on a number line, now remember this is an and situation, so we've got to take into consideration what this is going to look like, where it's going to look like some pieces overlap. My smallest value here is negative 4. The larger of the 2 x values is 1. Negative 4 is going to be a closed circle, okay, because it is included. It is x is less than 1 is going to be an open circle. That means it's not included in our solution. It's just a space holder for us. Now, any value that is between negative 4 and 1 would fall right in this area. So just to give you an idea of what solutions could be, a solution could be a lot of different numbers, but let me just pick the integers here. So a solution could be negative 4, a solution could be negative 3, a solution could be negative 2, negative 1, 0, but a solution could not be 1 because that is at an open circle. Okay, a solution could not be -5 because that does not fall in that area where the two graphs overlap. All right, let's go on. So that's problem number 1. Okay, let's go on to problem number 2. Oops, so I didn't get number 2. I actually picked up number 4. So number 4, this is an OR compound inequality. Now we're going to go ahead and solve for x in both given equations. So I'm going to go ahead and take this -1 and add 1. So then I will have 3x is less than -7 plus 1 is -6. Now I'm going to go ahead and divide by 3, and that's a positive 3, so I don't have to flip or reverse our inequality sign. Okay. So then I have x is less than -2. Okay, this is an OR statement, so keep in mind what that means. What's our graph going to look like at the end? So let's go to the second inequality. I'm going to take this positive 8 and subtract 8 from the other side. So I have -x is less than -5. Now, I cannot have this negative in front of the x, so I have to figure out how to get rid of it. How do I move it? If you remember, this is actually a -1 here. So it is -1 times x, so we can actually go ahead and divide by -1. Okay, but paying attention, we're dividing by a negative number. So that means we're going to have to reverse the inequality symbol. -5 divided by -1 gives me +5. Now, when I graph this on the number line, -2 is smaller than 5. -2 is an open value. 5 is also open. Now, I need a number that x is less than -2. So -3 would be less than -2. So that means we're going to shade to the left. Now on the other side it says x is greater than 5. So a number that would be greater than 5 would be 6. So in this case, we're going to shade to the right. Right? This would be an OR compound inequality. All right, let's go ahead and look at number 5. Now number 5 is also an OR situation. So let's go ahead and solve each of these inequalities separately. So I'm going to take this -11 from the left side of the inequality and add 11 to the right side of the inequality. So we'll have 8x is less than 8. Now we're going to divide both sides by 8. X is less than 1. Okay, there's my first solution to this inequality. All right, now the other side, we've got +10, and I'm going to take that +10 and subtract it from the right side of the inequality symbol. So I will have -3x is less than or equal to -12. Now we're going to go ahead and instead of being -3 times x, we're going to divide by -3. Because we're dividing by a negative, we need to pay attention to flipping or reversing our inequality. So we are going to be left with x is now greater than or equal to 4. Okay, let's go ahead and graph those on a number line. Now I know you have number lines listed on your worksheet, so you're just looking for the ones that you can match it with. And on that worksheet, we are only going to use 8 of the 10 graphs, so please do not look to use all 10 of them. Okay? Now I have 1 and 4. 1 is in less than, so it's an open circle. 4 is greater than or equal to, so this is a closed circle. It is an or statement, so we've got some clue of what it's going to look like. X is smaller than 1. What number is smaller than 1? 0. So this one here will face to the left. Over here, I have X is greater than or equal to 4. So a number that would be greater than 4 would be 5, so this one would point to the right. Again, we have an idea of what these OR statements or these OR graphs look like, so that should help us with some guiding information. Okay, last question to do together is number 8. On number 8, it is an AND statement. If they don't put OR in there, then we know that this is going to be an AND statement. So I should have 2 that I am looking at here. So let's see. Trying to get my pen to load. All right. Not sure why it doesn't want to work for me. Here we go. So this is an AND. So I have, that would be my first equation. So negative 2 is less than 2 times negative 3x plus 5. And my second equation starts right after that first inequality. And then that's 2 times negative 3x plus 5 is less than or equal to 10. Okay, so now that I've got my 2 inequalities separate of each other, again, we don't have to do it that way, but that's the method we're practicing. We're going to go ahead and do distribution first so we can get rid of these parentheses. So we are going to multiply negative 2 times everything in the parentheses. So I will have negative 2 is less than negative 6x plus 10. Now we are going to move this plus 10 to the opposite side of the inequality as the inverse, so it'll be a negative 10. Negative 2 minus 10 gives me negative 12 is less than or equal to negative 6x. Now we're going to go ahead and divide by negative 6. Negative 12 divided by negative 6 is 2 is less than or equal to x. Oops, I said it, but I didn't think it. So it's 2 is greater than or equal to. Why is that? Because we divided by a negative number. Okay, all right, now let's go to the other inequality in this same sentence. So go ahead and use distribution first so we can get rid of those parentheses. So then we have 2 times negative 3x is negative 6x. 2 times 5 is positive 10 less than and equal to 10. Now we're going to move this positive 10 to the other side. So I will have negative 6x is less than or equal to 0. Now I'm going to go ahead and divide both sides by negative 6. And I will have x is greater than or equal to 0. Remember, whenever we divide by a negative number, we have to reverse the inequality symbol. Okay? All right, so on a number line, what do I have? So on this number line here, I have 0 and 2. 0 is smaller, so it's going to go to the left. 2 is larger, so it goes to the right. X is greater than or equal to 0 is a closed dot. X is less than or equal to 2, so that's a closed dot. And is any number between and including 0 up to and including 2. Okay. All right. I hope this helps you, and then make sure you complete the other 4 examples and have them ready to submit in class tomorrow.